Good Earth Day, everybody, and welcome to this presentation that was originally given on a Facebook Live through the UTRGV Environmental Awareness Club on April 21st. We are now at Earth Day, April 22nd, and today is the 50th anniversary. And why not discuss changes that we've been seeing in the climate across the Rio Grande Valley? So my talk is entitled Record Warmth, Extreme Rainfall, Longer Droughts, Higher Tides. Has climate change reached the Rio Grande Valley? We'll explain over the next 30 minutes what we think is happening here. I'm Morning Coordination Meteorologist Barry Goldsmith with the National Weather Service in Brownsville, serving the Rio Grande Valley, and let's get started today. So global warming, where are we now? This is a chart showing the global average temperatures based on a long-term average going back to the 1800s, that's the zero line, and showing the departures from average from the Industrial Revolution period just after the Civil War. Again, this is the worldwide Industrial Revolution, all the way to the present day. You'll notice two things: period of below average temperatures through the early 20th century, then another period of up and down temperatures, warmer and cooler, through 1980, followed by an exponential rise, as shown by the mouse pointer here, going all the way until the current day. We also know this as the hockey stick graph. If you look at Professor Michael Mann at Penn State University, he has an example known as the hockey stick graph that goes back hundreds, if not thousands of years, with the blade of the hockey stick, the last 40, going back to 1980. It shows up clearly here in terms of land temperatures. But we have to look at more than land. After all, there can be biases in land based on friction, based on being near cities versus being in rural areas, mountains versus valleys. That's not the case on the sea. And here we're showing the oceanic heat content anomaly during the 1900s, from the mid-1950s all the way to the present, and we see the same thing beginning in 1980, some ups and downs, and then from 1990 until the present day, the oceanic heat content is on the hockey stick blade once again. Now, why is this a shorter period of time? Because there is lag in terms of the heat capacity of the ocean to see the impacts of what's going on land. So it's not surprising that it took a little bit longer into the late 20th century to see the hockey stick begin. But sure enough, it has begun and is going exponentially up in terms of temperature values over the last 20 years. So about 15 years ago, former Vice President Al Gore made a compelling documentary movie called An Inconvenient Truth. And he took a lot of the information he was building over the years, going back to the 1980s, and put that into a form updated for the 21st century. What he's going to describe here, which unfortunately you won't be able to see, but you will be able to hear, is how the carbon counts have changed dramatically over the last 50 years compared to what they were for the past several hundred years, and also comparing that with where they should be in the current day. We'll explain that on the following slide after he's done speaking, that will clarify what he is speaking about in this short video clip. So without further ado, here's the video clip from Al Gore.
Now, if you'll bear with me, I want to really emphasize this point. The crew here has tried to teach me how to use this contraption here. So if I don't kill myself, I'll... It's already right here. Look how far above the natural cycle this is, and we've done that. But ladies and gentlemen, in the next 50 years, really in less than 50 years, it's going to continue to go up. When some of these children who are here are my age, here's what it's going to be in less than 50 years. You've heard of off the charts. Within less than 50 years, it'll be here. There's not a single fact or date or number that's been used to make this up that's in any controversy. The so-called skeptics look at this and they say, so, that seems perfectly okay. Well, again, if on the temperature side, if this much on the cold side is a mile of ice over our heads, what would that much on the warm side be? Ultimately, this is really not a political issue so much as a moral issue. If we allow that to happen, it is deeply unethical.
So there you have it, and let's show what this actual data he's speaking about looks like on the next slide. So here's the chart that Al Gore was talking about. It goes all the way back to 800,000 years before the present day. And you can see the rises and the runs, the natural cycle, if you will, of carbon dioxide in the atmosphere. And warm periods tend to correlate well with higher carbon counts and cooler periods with lower carbon counts, typically ranging from the mid to upper 200s in the higher values down to the low to mid or mid to upper 100s in the lower counts. Their highest previous concentration was seen about 350,000 years ago. That was a mini warm period. There's also little ice ages in there. But notice what's happening at the very end. Within the last 50 years, we had risen well above 300. We'll show you exactly where that is in the next slide. But as of 2018, we were at 407.4, which is literally what Al Gore's chart, if you can imagine when he was discussing the raised scaffold, what it looked like. And he said within 50 years, and we'll show you what that means. And even 2 years later, we've already gone up another 7 parts per million from 407 to 414 earlier this year in February 2020. So think of this chart as a snapshot of the most recent years, very small period of years going back to the 800,000 we showed before. This goes from 1975 to present day, which is 45 years, and we've gone up nearly 100 parts per million. In the past, with natural cycles alone, that would take tens of thousands of years, and we've done that in just 45. Is that a problem? Yeah, I think so. The up and down nature of the curve, or the sawtooth nature, is basically due to the times when trees are fully leafed versus times when trees are bare or just beginning to be leafed. When they're fully leafed, we have a sink of carbon, so the values actually go down in the late summer, early fall. And then by late winter, early spring, when there's been no leaves on the trees, the carbon stays up in the atmosphere, hence the higher values on this jagged edge. But no matter what, you take the mean of the values for the whole year, and we have gone up nearly 100 parts per million in just the 45-year period. So let's take what we've been discussing globally and bring it down locally into the Rio Grande Valley. Shown here are the mean average temperatures for Brownsville dating back to the late 1870s, the period of record, which by the way is the longest lasting period of record we have at any site in the Rio Grande Valley. And you'll notice two interesting things: a generally even Steven up and down trend with not much of a rise or fall in the late 1800s to the early 1900s, then a bit of a rise into the early to mid 1900s, and then a notable drop in the 60s and early 70s. But the key is in the red outlined area. Notice the exponential increase shown by this green line known as a Loess, L-O-E-S-S, Loess curve. And that red area that's outlined, if you look to the lower right, you'll see it zoomed in even more, and you'll notice it's a gradual rise, steady, through about 2010, and then a rapid rise from 2012 until the present day. And that shows up on the left-hand part of the screen, the chart here of ranked temperatures. These are the peak values going all the way back to 1878 and when they occurred. And notice that in the red outlined area, the top 6 all occurred in the 2010s. Think about that for a minute. We go back to 1848, that's 142 years of record, and the top 6 hottest years all occurred in the 2010s, which means most recently. And that is, my friends, a troubling trend. So we're bringing it a little closer to home for many of you who are living and working in the McAllen area, going to school up there in Edinburgh. Not much change from what you saw in Brownsville. The only difference here is that the period of record is about 80 years, going back to 1942. You see the dip in the 60s into early 70s, and then you see the steady rise and then that rapid rise of that green line, that little tail there going up. And if you look at the lower left corner of the screen, you'll see that 7 of the top 10 hottest years going back to 1942, actually for the full year, occurred between 2009 and 2019. So the trend is troubling no matter where in the Rio Grande Valley you look. We are all going up in average temperature, but rapidly increasing, and we're seeing record warm year after record warm year. So you're asking about 2020. Where are we sitting right now in the year 2020? We are sitting at number 2. So for the year from January 1st to April 20th, which is the data we had available at the time of this presentation, Harlingen, Brownsville, McAllen are all already number 2 warmest all time, which means that we're on pretty good track to maybe finish in that top 10 once again and continue the troubling trend. So how do we know this? Why do we think that's a pretty good possibility? Well, we're guaranteeing that 2020 will be maybe number 1, certainly near number 1, hottest, and we're saying again, because 2019, 2016, 2017, for some locations 2018, we're all ranking in the top 5, hottest all time, which means it's close to number 1. So you can see here the forecast for all these 3-month periods, beginning May, June, and July, 3-month average, all the way to October, November, December of 2020. There's not one of these periods that is below a greater than 50% likelihood of above average temperatures. Now think about that for a minute. I use the term likelihood. That means it's likely. When you say there's a chance of rain, we usually say 50-50 or lower. When we say rain is likely, it's 60% or greater than 50% or higher. And that's where we are for all 5 of these, in fact all 6, I don't show all 6 of them, but all 5 shown here of the 3-month samples. That's pretty high probability for such a thing because you're also looking at probabilities of equal chances, which typically ranges from like 25 to 33%. And then what's left is the probability below average of temperature. So guess what? We are looking at McAllen being very low with the below average chances in May, June, and July, and it goes lower still in the heart of summer, what we call the meteorological summer of June, July, August. So June, July, August, it's a greater than 60% probability of above average temperatures, and that's a long lead forecast issued 1.5 months before the start of the period. And then for July, August, September, we're back to 55% or so in the above 50. And even August, September, October, we're above 50. And that's pretty impressive forecast. That means a 3.5 and a 2.5 month lead time to make to the beginning of the period is still showing a likelihood, not just a chance, but a likelihood of being above average. And if this all verifies out, because if the probability is high, then you're probably going to be above average. And if we're just 1 or 2 or 3 degrees above average from here on out, we've locked in another top 5 finish. So the good folks at Climate Central have kind of put into perspective how the global warming is affecting all areas of the country, but especially the South, and especially during the hotter part of the year. Notice the one area of concern here is indeed the Rio Grande Valley, and there's only one spot that has a maroon color. So what is that maroon color? It's the change in number of days with heat index of 90 or higher since 1979 based on the annual numbers. So let's say in 1979, McAllen had 55 days with a heat index of 90 or above. Now we have 85 or more days in 2020, with the trend continuing to go up. So it's not the actual number of days, it's the increase in number of days, which is 30 or more, and that's in McAllen, and that is the heart of the Rio Grande Valley. Now let's look at another value in the upper right corner here. This is the change in number of 105 or greater heat index days, or feels like temperature days. And McAllen leads the way again with a whopping 22 more days, hitting 105 or more of heat index compared to 1979. And we saw this in 2019. We actually had over 20 days in McAllen with heat index blasting above 111, which is our advisory level. And many of those days went over 115, I think a dozen of those days, which is our warning level. And if this is a troubling trend, as we mentioned before, we have to do some adaptation to the future heat that's coming here, even in a place that we all understand is quite a bit hot. So now let's shift gears from the troubling temperature trends to rainfall or lack thereof trends. And I titled this slide and this section, Worsening Drought. What do I mean by that? On this particular slide, I'm showing how the extremes manifest themselves just 10 years ago. Between October 2009 and September 2010, known as the water year, we had near record or record rainfall due to a multiple number of reasons, including a strong El Nino in the winter that year, followed by Tropical Storm Alex, which dumped a lot of rain over the valley, a pretty wet summer overall, and then ending with Tropical Storm Hermine, especially in the lower valley, which is the highest values you see in Cameron County. When all was said and done at the end of September, we had these values that were between 30 and almost 50 inches of rainfall, way above the average, and as you can see in here, number one. Just 1 year later, another water year ahead, we had record to near record dry. Areas that had received 30 to 50 plus inches of rain were now only getting 5 to 15 inches of rain, which is more like the southwestern U.S. deserts of Arizona and California than here in the Rio Grande Valley. And the pictures below tell the tale. In midsummer, late summer, it was green and beautiful and lush across Brownsville. You go to early summer of 2011, it looked like a desert out there, and this particular cow is really struggling to get water and is very thin. Let's take a look at the drought monitor from then. So at the end of that wet period, we were great. We were in no drought category. In fact, we were abnormally to much above average precipitation through that water year that ended in September of 2010. But just 8 months later, that 75% of the state is in the highest level of drought, exceptional drought, and the Rio Grande Valley is also part of that 75%. In fact, 100% of the populated Rio Grande Valley in late June was in the highest level of drought, exceptional. We had gone from beautiful green lush grass to nothing growing at all and dead grass in just 8 months. So we've just mentioned how quickly we could go from incredible amounts of rainfall to incredible amounts of drought and dryness. And while drought is the lean, we still have rainfall extremes. So let's take a look at 4 cases going back to 2015. October 2015, the remnants of Hurricane Patricia came through the valley on top of some heavy rain that had occurred earlier and the following week. We ended up with more than 14 inches of rain in places such as South Weslaco and east of Raymondville. In 2018, we had what we now know as the Great June Flood of 2018 for the Rio Grande Valley. These values shown here between 18, 16, 14 inches, in some cases were more than what Hurricane Beulah dropped on the region. That flood, because it hit so many urban areas, caused over $200 million in property damage. Just 3 months later, September, we almost got hit again in the valley, but this time the heaviest rain spared the valley, but unfortunately flooded the ranches of Jim Hogg Brooks, northern Hidalgo, and northeastern Starr County, with very similar rainfall amounts between 14 and 20 inches. And then 1 year later, almost to the day, in late June 2019, we had between 8 and 15 inches in the Harlingen, Mercedes, Raymondville area, some of those locations overlapping what we had seen just 1 year earlier. So why do these extremes matter? Well, first, let's take a look at the pictures. So now let's match what those rainfall totals you just saw in the prior slide to what it looked like on the ground with each case. In late October 2015, this was a drone footage from Willacy County. Now, Willacy is a very rural farm county, and in October, the fields are plowed over, but unfortunately, the soil type is very impervious. It's a clay, silty loam. And when rain falls at rapid rates, it has nowhere else to go but up. So we had what we called Lake Willacy County in late October 2015. We mentioned the Great June Flood of 2018 in the Rio Grande Valley. It affected McAllen, Mission, Mercedes, the three M's, but all the way over to the lower valley as well. This photo taken east of Los Fresnos towards Bayview. You can see lots of water in fields and also in some homes there. To the lower left, it's also June 20th, 2018. This was the Mercedes flood. There are people here walking in the high waters. We estimated 4 to 5 feet of water near the frontage road along Vermont Avenue. And then the right picture just happened on June 24th, 2019, almost 1 year to the day. And that is the northwest side of Harlingen under quite a bit of water, 1 to 3 feet worth. We saw the same type of pictures in Raymondville. And we think this event caused about $100 million or more in property damage on top of the $200 million event from 2018. So this particular matrix or chart has a lot of numbers on it, and you might not understand what I'm looking at. But what I want to emphasize here and kind of soapbox on for a minute is the idea of a 100-year flood, a 500-year flood, a 1,000-year flood. Folks, there is no such thing. What we look at are the average recurrence interval measured in years, which is a probability. So when you see 100 here, it does not mean a 100-year flood. It means there's a 1 in 100 chance, a 1% chance in any given year that you will see this amount of rainfall, which could contribute to a flood event in the Rio Grande Valley, in this case, Weslaco. 200 is the same thing. 1 in 200 probability, that is 0.5% chance. 500 is a 1 in 500 chance, that's a 0.2% chance. And the 1,000 is a 0.1% chance. If the atmosphere wants to play in the devil's sandbox and make it rain hard like Noah's Ark or Winnie the Pooh, it's going to do it. It could care less about how many years it has been. And we just showed you that on the prior slides with those images, just 4 in 3 years. Well, let's go over them one by one. So here is the 2015 event. We're basing it on the Hydrologic Atlas 14 for Texas. In fact, we base the next 3 slides on that. This is based on Weslaco. What's interesting here is looking at 3 and 6 hour rainfall totals. What we actually saw on the ground was in these ranges, and they ranked as a 1 in 200, 1 in 500, or even 1 in 1,000 event for Weslaco South Side, where we had 5 feet of water in some apartment buildings on that particular October day, the 24th in 2015. But I'd like to show the 50, the 1 in 50 probability, which is a pretty low probability, right? Look how long it would normally take to get this rainfall to meet a 1 in 50 probability. 11.5, 12 inches in 3 or 4 days, and we got all of that and more in 3 to 6 hours. It just gives you some perspective of how much rain fell, how quickly. Because you remember, flooding is based on 2 things, rainfall amount and rainfall rates. So both matter in terms of what you'll see in terms of impact on the ground. 2015, let's move on to the 2018 event. Same deal, right? We had rainfall occurring in 60 minutes to 3 hours. The values within 60 minutes for 3 consecutive hours of it range from 4.5 to 5 inches on the east side of Weslaco. We believe may have dumped 18 inches in the Las Brisas neighborhood, with an official measurement of over 15 inches at the cooperative site by the Mid-Valley Airport. These were the hourly rates, and notice they are 1 in 100 to 1 in 200 probability events, but the 3-hour rate, which was 15 inches, is off the charts. It is actually above 10.3. The actual value was 15 to possibly 18, which probably puts it in the 1 in 2,000 or greater off the charts, as we say. And then going back to the 1 in 50 probabilities, once again, a 3 to 4 day period to produce not as much rain as fell in just 3 hours in some cases, 11.5 to 12 inches in the Weslaco area. And it kept going in 2019. This time we used Harlingen as our baseline. And again, the same deal. Using the 6 hour time frame, which is how long it took that 8 to 15 inches of rain to fall, we are once again at the 1 in 500 to 1 in 1,000 probability situation. So that means a 0.2 to 0.1% chance in a given year this can occur. Well, it occurred. And then the 1 in 50 probabilities are 4, 7, even 10 days it would take to get that much rain in Harlingen from the rain that actually fell in just 6 hours. So if the atmosphere wants to play in what I call the devil's sandbox, it will play and it will rain and it will flood, and it does not care about the number of years because it has nothing to do with the number of years. So we can show the drought to flood to drought to flood. This goes back to a saying made 100 years ago, roughly 100 years ago, by a Texas meteorologist who said, quote, "Texas is a state of perpetual drought broken by the occasional devastating flood." And here's our proof. June 10, 2018, this is near my neighborhood, bone dry, nothing's growing, grasses are brown. June 19th, 2 to 3 feet of water from a 6-inch rainfall event. Labor Day weekend, we're dry again. A little bit of green shoots there left over, but mostly brown. And then by mid-September, a few weeks later, we had enough rain to turn it green, and fortunately for the lower valley, not flood a second time. So sure enough, that statement seems to be holding true, and maybe one of the outcomes of climate change, global warming, more frequent transitions from drought to flood to drought to flood, like the very prescient meteorologist said in 1920. So look at 2017 for drought. What happened? Post-Harvey, disregarding the valley, which missed Harvey, much of Texas, especially east and southeast Texas, was not only non-drought, but they were abnormally moist. In fact, near record moisture due to 30 to 60 inches of rain that fell with Harvey just after the event in late August. And just 3 months later, lack of rainfall, continued hot temperatures, and we have moderate to severe drought in some of the areas that got 30 or more inches of rainfall just 3 months earlier. It doesn't take long. The soil is like a sponge now. It absorbs that moisture. Dry, hot, greasy conditions evaporate it away, and it's just not lasting long enough to get deep into the soil to really help. So what do I mean here by latent heat from this, shifting the extremes? Shown on this slide is the departure from average of global sea surface temperatures, with an inset on the lower right of the Gulf of Mexico, which happens to be number 1 in terms of those departures. In fact, somewhere between 4 and 10 degrees Fahrenheit as of that particular date, in this case, April 19th. So you're probably thinking, wow, this is going to be some hurricane season because the fuel is really available. Well, yes, but we also need the other elements to build the engine for the hurricanes, and that's no guarantee at this point. So we'll talk about that later as we get closer to hurricane season. But for spring, we do know that the atmospheric jet stream can still be energetic enough to lift some of this moisture into rainfall. And when you've got more available energy from latent heat, you can have the potential for more intense and potentially widespread flooding rainfall anywhere along the Gulf Coast, including the Rio Grande Valley. If you notice what's happened in the deep south of the U.S., from Louisiana to Georgia and everywhere in between, there are rivers in flood. There's been near record rainfall for some, partly we think because of the ability of the atmosphere to rain out very heavy amounts of rainfall because of the amount of latent heat in the system. Could it be Texas or South Texas or the Valley later on this spring and summer? Most certainly. If the atmosphere wants to play, it could rain and rain a lot, despite the fact that we're still in severe to exceptional drought. So here's a perfect example of what I mean by Texas is a state of perpetual drought broken by the occasional devastating flood. This information was provided to us by USDA Farm Service agent Mr. Benny Cano, who works out of Edinburgh. And it was provided in mid-August of 2019, about a month and a half, almost 2 months after that big June flood. And what he says here is that extreme heat has caused irrigated crops to have to be watered more often. Who would have thought that after the June rains? Well, when you have no rain, very hot temperatures, occasional low humidity and wind, on top of the fact that deep soil moisture is just not deep enough, it can dry out rapidly. So he mentions here other crops have suffered between 50 and 60% of average of suffering or loss based on the reality of no rain and dry land crop suffering. The last one is really important here. Dry land pastures are extremely dry due to the excessive winds and heat. In just a few days, the grass was green and it went to burnt up brown. That's our reality here in the Rio Grande Valley right now. We have a very high sun angle. We've been having very hot summers. And that combination, as well as the forecast you've already seen, means that we're probably going to see more of this issue continuing, not just now in spring, but even worsen as we get into June, July, August, and perhaps beyond. So far, we've spoken about the troubling temperature trends that we've seen, especially in the last decade, a sign of climate change and global warming here in the valley. And we followed that with the flip-flop extremes from rainfall and flooding costing hundreds of millions of dollars over to the drought side, also costing perhaps hundreds of millions of dollars. And sometimes that transition is occurring in a year or less. The final factor in climate change, especially for our area since we have a wonderful beach, is sea level rise. And here's some photos from South Padre Island that indicate what is starting to happen, what could become more frequent as we move on in time. On the left side, it's a beautiful day in October, temperatures in the 80s, surf in the 80s, and notice that the shallow slope rise from 0 feet above sea level to about 8 feet or so above sea level in the vegetation on the dune line. A month later, look what happened. There is no longer a rise. It's basically 0 all the way up to the dune line. And instead of a gradual slope and a hill of dunes, we now have a wall of dunes. We have calved out the sand, and if you stood up and took a picture in front of it, it looked like a wall of sand and vegetation behind you, which it was. That came from two things. One, the king tides of the fall, which do occur normally, but the reality of constant above predicted values from what they should be based on years and years of record, which is something we keep seeing more of. Of course, the atmosphere has a role to play. We had strong high pressure set up in the northeast US. These are beautiful October days, but it also spreads all the way or sprawls all the way into the Southland, even to Florida. And on the west side of that, or the southwest side, the long easterly fetch of water and wind will begin to pile up water onto our beaches. So that's not unusual. It's the degree of difference from predicted that's becoming more a norm and perhaps a new normal. So how does this increased sea level rise look in terms of data? We have a tide gauge at Brazos Santiago. This is just inshore of the beaches of South Padre along the north jetties at Isla Blanca Park. And in 2019, between the dates of the 15th of October and the 1st of November or so, we had a period where we were seeing near moderate flooding. And what we saw was, in those cases, the calving out, or the walling off, if you will, of the dunes at thin beaches on South Padre, as well as some other tidal flooding at boat ramps and other locations towards the ship channel. And this is the 2019 case. And these are unverified data, but we expect them to be pretty accurate. So when they're verified, they will turn a green color. So that is the case for 2019. Just 1 year earlier, check this out. While the values compared to flooding are lower, the values compared to the predicted levels are still about 1 or more feet higher than what they are predicted to be the prior year. And before this on the map, we had the outflow, if you will, of the ocean from Hurricane Michael, which produced a flood value in the 2 to 2.5 range and was the worst flooding we had seen on the beach since Hurricane Ike in 2008. But the point is, you're seeing this frequently. This is the king tide period back in the fall of 2018, which we just showed the same situation for 2019. And here's the most recent case of tide values above predicted levels, combined with the fact that these are spring tides. So here we're looking at tidal values as high as 1 foot above predicted into the minor flood range. And on that particular day, April 12th through April 14th, we ended up seeing water that reached the dune line just barely at that thin beach that we showed in the pictures before. The beach wasn't totally flooded, but you really couldn't put any equipment on it if you wanted to. But once again, it's another case of above predicted tides that we've been seeing quite often over the years. So is this a new normal? Do we need to present the new predicted tides to be closer to what we're seeing? And that may be something that we'll do in the near future to be more accurate about what is really happening out there with sea level rise. So in summary, these are our bottom lines. Number one is that the Rio Grande Valley temperature trends in the 2010s are troubling to say the least, and they could be alarming if they continue into the 2020s. And as we showed you earlier, we're already ranked number 2 in mid-April, and we've got a whole rest of the month to get even hotter, and that summer forecast gets even worse. So we've got a real shot at becoming #1 and continue this troubling trend that began in the 2010s. If this happens, the impacts are great. We obviously have to deal with people impacts, heat injuries, and potential deaths for those not prepared, and including migrants that are trying to cross the river. And we saw this unfortunately last June. We'll have rapid transition to drought and longer pronounced droughts when we're in them. So as we saw with Mr. Cano's response from the great rains of late June 2019 becoming 50 to 60% dry land crop loss just a month later or so, that's where we seem to be at in a new normal. Water management issues will be top of the list, as well as crop production issues continuing into the future. What I didn't show here is that the current level at Falcon Lake is only 30% of capacity. There's not much water to give upstream from Amistad, and if we have a very high evaporation rate spring and summer, we're not going to have a lot of water to give to our communities, much less our crops. So it's something that communities will have to be considering, and folks may need to look at conservation efforts through late spring and summer if we don't get the necessary rain and even flow into the river. Energy use issues, I mean, look what happens when we get really hot. We run the air conditioning a lot more frequently, and when that happens, sometimes Texas will force brownouts to ensure that we don't overwhelm the state system of energy control. And what's going to happen in the next 30 years when we balloon our population to an expected 4 to 6 million and combine that with the global warming we're seeing and expecting to see continue or even accelerate for 30 more years? Can we survive it? If we're like Phoenix, will we be able to get water to, in terms of temperatures, water to allow people to live here? Question that needs to be answered by all of us as we move forward. So your bottom lines on the water side of things, remember there's no such thing as a 500, 100, 1,000 year flood. It's only probabilities. And these values may not even be relevant anymore if we're adding more frequent extreme cases. As we have seen, since 2015 to 2019, we have had 4 1 in 500 plus events. It certainly didn't take 10 years to get there, and definitely didn't take 500 years to get there. So we may have a new normal here. Rio Grande Valley drainage is going to need to build for this new normal. Now, what does that mean? Well, some communities are only built to a 1 in 5 probability event and not built to the 1 in 100. Maybe they should consider 1 in 100 or even 1 in 200 as a better way of assessing the risk. Now, it's a cost-benefit, risk-reward benefit analysis that needs to be done. But somewhere in the middle, we'll probably save more homes from damage, even though we'll still get some issues when we have too much rain too quickly. The long-term impact of the floods is negated, though, by excessive heat and drying. We saw that in 17 through 19, and if we do get some big rains this May and June, we'll probably see it again by July and August of 2020. Finally, on the coast, the above predicted tides dominate near or below predicted tide periods by at least 5 to 1, if not more. So maybe it's a new normal. We have to recalculate what predicted tides are and base our above and below on that, because if we have sea level rise that's persistent, we need to be more accurate in what exactly we're predicting for our tides so we can determine where the safest place to build or perhaps move back off of the beach is as we reach into the middle part of this century. So that concludes our presentation. Say thank you all for sticking around. I am here for questions, certainly virtually. You can catch me on email. I'm at barry.goldsmith@noaa.gov. If you're into social media, find me there. I'm at WXDancer, Weather Dancer for short. I am on Twitter, Facebook, and LinkedIn. And there's my phone number as well. That is my cell number, so feel free to call me. I will be happy to answer your questions. Thanks again to Stephanie and the UTRGV Environmental Awareness Club, and enjoy your Earth Day, everybody.